Within 48 hours of 3I/Atlas's closest approach to Mars, the most powerful transmission coming from our solar system wasn't a radio signal or a burst of plasma, it was silence. NASA blamed a federal funding freeze, claiming communication lines were tied up in bureaucracy. The European Space Agency said their data was still processing. And China, whose Tianwen-1 orbiter has released over 14,000 images of Mars since 2021, suddenly stopped transmitting altogether. No statements, no thumbnails, not even an acknowledgement the encounter happened. For the first time in modern space history, every major nation observing the same event responded with the same action. Nothing. This wasn't a delay, it was a disappearance. Normally, this kind of alignment between probes, NASA's MRO, ESA's Mars Express, China's Tianwen-1, the UAE's HOPE, would trigger a global celebration of shared discovery. Instead, we got total blackout. And in the digital age, where every photon and frequency is tracked in real time, silence itself became the loudest signal of all. By every measurable standard, this should have been the most documented interstellar encounter in human history. NASA's Mars Reconnaissance Orbiter, equipped with the HiRI-C imaging system capable of resolving objects smaller than a meter, was perfectly positioned. It could have captured 3I/Atlas as it sliced past the Martian sky in crystal clarity. The European Space Agency's Mars Express and Trace Gas Orbiter were tasked with measuring the object's spectral fingerprint, analyzing gases, metallic composition, and thermal emissions in real time. The United Arab Emirates HOPE probe had atmospheric sensors ready to detect ionization trails as Atlas crossed Mars' magnetic wake. And China's Tianwen-1, sitting in near-ideal geometry, could have returned full-resolution visuals from multiple passes. 5 spacecraft orbiting one planet, each built by competing nations, all aimed at the same object during the same brief cosmic window. A geometric configuration so rare it won't repeat for centuries. Under normal conditions, that lineup would unleash a flood of data, press releases, image mosaics, spectrum charts, orbit updates. Scientists would be racing to publish, nations competing to claim discovery credit. Instead, the world got nothing. No raw images, no preliminary readings, not even a timestamp acknowledging transmission. In an age where information travels faster than light used to, that silence is not technical. It's intentional, because when every eye in orbit blinks at once, you start to realize we weren't staring at a lack of data. We were staring at a decision. Before the silence, 3I/Atlas had already rewritten half our models. Its chemical ratios defied everything we thought we knew about comet formation. Spectroscopy revealed a CO2 to water ratio of nearly 8.1, chemistry you'd expect only in the frozen outskirts of infant solar systems, not in a body passing through the warmth of ours. Then came the nickel lines, bright, distinct, appearing without their natural companion, iron. That's metallurgically impossible under every known model of stellar evolution. And still, it wasn't done surprising us. Unlike any comet we've tracked, 3I/Atlas showed no outgassing wobble. As sunlight struck its surface, there were no thrusts, no visible jets of vapor, yet its trajectory remained astonishingly smooth, almost as if perfectly balanced. Its rotation wasn't chaotic either. It spun with machine-like precision, consistent, stable, unwavering. Even its light betrayed strangeness. Polarization readings returned extreme negative values at narrow phase angles, optical behavior no comet should display. It reflected light like something engineered to do so, as if its surface had been sculpted, not eroded. That's why this encounter mattered so much. For the first time, 5 separate instruments from 5 different nations were poised to study these anomalies together. Cross-verification, high-resolution imaging, simultaneous spectroscopy, the perfect test of truth. This was the moment when physics, chemistry, and probability would collide, when we'd finally decide whether Atlas was merely an interstellar oddity or something unprecedented. And then, right when truth was within reach, every eye blinked shut. Here's what unsettles scientists the most. Not the data itself, but the silence surrounding it. NASA blames politics. The European Space Agency cites processing delays. And China, usually eager to showcase its technological edge, offers nothing. That alone breaks precedent. Beijing has never missed an opportunity to display superiority when Western agencies stumble. In moments like this, when American communications falter, Chinese mission directors typically accelerate their releases. Proof of capability, of precision, of dominance, but not this time. Not with 3I/Atlas. This time, every nation watching simply stopped. For those who've studied the politics of discovery, that pause feels familiar. It echoes something conceived decades ago, the SETI verification protocols, rules quietly agreed upon during the early search for extraterrestrial intelligence program. If a potentially civilization-altering discovery occurs, no single nation speaks first. Data must be cross-verified, interpretations aligned, and public messaging coordinated across borders. It's a system built for prudence, but one that easily blurs into control. Maybe this global silence is caution, scientists buying time, governments drafting language, or maybe it's fear, the kind that drives institutions to conceal what they can't yet explain, because once something leaves the realm of chemistry and trajectory, it enters the realm of psychology and geopolitics. The stakes shift from understanding what it is to deciding who gets to say what it means. For NASA, it's about credibility. For ESA, cooperation. For China, reputation. For the rest of us, it's about truth. And yet, through all that human noise, the object itself keeps moving, indifferent to our debates, unbothered by our hesitation. Maybe it's just ice and dust. Maybe it's something far greater. But this much is undeniable. When silence crosses borders, it's no longer science, it's strategy. So what could possibly justify such a unified silence? It wouldn't be a blurred streak or a corrupted signal. Those happen all the time. It wouldn't be an ordinary dust plume or a faint reflection. Those don't terrify institutions into coordination. It would take something unmistakable, something that demands explanation before the world sees it. Maybe what those probes captured wasn't random geometry at all, but structure. Straight lines where no natural process should draw them. Surfaces too even, too precise, too deliberate. A pattern of heat across its body that suggests thermal regulation, not random solar heating. A rotation so exact it borders on programmed motion. Not the tumbling chaos of rock, but the deliberate rhythm of a machine. Imagine a surface reflecting light in perfect periodicity, glinting at intervals that almost look timed. An object that responds not to gravity or sunlight, but to observation itself, orienting as if aware of the gaze upon it. For scientists, that's not just discovery. It's the kind of evidence that could collapse careers overnight if misinterpreted. Because what if they're wrong? What if a calibration error mimicked geometry, or a cosmic ray streak created symmetry where none exists? That's the real fear, not fear of the object. Fear of the wrong sentence. The wrong word in a public briefing could rewrite headlines, panic markets, and fracture decades of scientific credibility. So instead, every agency retreats into the same unspoken rule: wait, verify, control. Somewhere, buried beneath firewalls and clearance levels, that first image may already exist, reviewed, debated, labeled, classified, until confirmation. And if it ever reaches the surface, if even one pixel matches the rumors whispered between labs, it won't just change astronomy. It will change how we define silence itself. Because somewhere in a locked lab, the first image may already exist. Of course, there are reasonable explanations. There always are. Data pipelines do clog. Instruments malfunction. Sensors drift out of calibration. It's possible that Mars Express is still processing spectral data, that high-res simply couldn't track a dim, fast-moving object across its field of view. Maybe the funding freeze at NASA genuinely delayed internal data reviews. And perhaps China's communications blackout was less conspiracy and more caution, waiting for others to publish before revealing their own. All of it fits on paper, but probability doesn't lie. Because when 5 independent spacecraft built by rival nations, positioned in different orbits, all fail to return a single confirmed frame during the most anticipated encounter in modern astronomy, that's not just bad luck, that's symmetry, and symmetry demands attention. Professional embarrassment might explain one agency's silence. Bureaucratic paralysis might explain 2, but 5 across 3 continents? That begins to sound less like chaos and more like choreography. So scientists continue their quiet modeling, governments draft talking points, and the rest of us watch the stars, waiting for anyone to break formation. Maybe the simplest answer is true, maybe not. But history tells us something unsettling. When logic runs out, coordination begins. Maybe this isn't a cover-up at all. Maybe this is humanity's first rehearsal, not for panic or disclosure, but for discipline, for learning how to face the unknown with composure instead of chaos. Science has always demanded 3 virtues: patience, verification, and restraint. The universe doesn't reveal its truths to those who rush. It rewards those willing to wait, to question, to measure twice before they speak once. Perhaps this global silence isn't born of secrecy, but of respect, a collective pause before translating something that might redefine what it means to know. Because if 3i Atlas truly holds a secret, whether carved in ice, metal, or light, it deserves precision before interpretation. In the age of instant answers and algorithmic noise, silence may be the last remaining form of intellectual courage. For the first time in history, rival nations, rival scientists, and rival agendas may have agreed, without signing a single document, that caution is wiser than spectacle. And maybe that's the quiet miracle no one expected. 3i Atlas hasn't united humanity through discovery, but through doubt. It reminded us that uncertainty is not weakness. It's the birthplace of wonder, because whether that unseen image reveals geometry or dust, whether the signal proves artificial or natural, the truth remains unchanged. 3i Atlas already accomplished something extraordinary. It forced all of us to look up together, to hold our breath, to synchronize our silence. Unity born of uncertainty, 3 nations, 5 probes, and 1 moment of silence that might echo for centuries. For the first time, the entire human species paused, not because we understood, but because we didn't. Somewhere beyond the solar glare, 3i Atlas drifts on, indifferent to our hesitation, carrying whatever truth it holds deeper into the light. And maybe this is the silence before the answer, the breath the universe takes before it finally speaks, because if this was the moment we fell quiet, what happens when it speaks again? If you think the story ends here, it doesn't. In the next episode, we'll decode the whispers hidden inside the downlink transmissions NASA didn't release, and what they might reveal about what 3i Atlas truly is.